Okay, so we're going to study velocity time graph, and we will be discussing some different aspects of these graphs. For example, over here we will come and let's say we have this sort of graph. Basically, our target will be that how to read a graph if it is given in our paper. So we'll see that how we will be reading it. Like you can see this a little bit blurry graph. If there is a straight line, a straight horizontal line like this one, like you can see in other graphs as well, you see, let's take some values over here. Like this is 5, this is 10, then this is 15. Let's say this is 17, and let's take some values of time as well, like 2, 4, any values. I'm just taking random values 2, 8, 10, 12. You see that at t is equal to 2 seconds, speed is 17 meters per second. At that time, t is equal to 4, speed is 17 meter per second, and so on. Speed is not getting changed. So when velocity or speed, particularly velocity, is not changing and object is moving in a straight line and its direction is not changing, we will say that its acceleration is zero, right?
Yes,
And
sir.
v is constant. V is constant and acceleration is zero, right? However, if you have a straight line like this one, as you can see over here, okay, let's say this is something that now it's a speed, it has an acceleration. Let's say this acceleration is equal to x. It is not zero because here um, this acceleration is constant, I would say, because the speed here we can say that velocity increases uniformly. Velocity or speed increases uniformly. That is why you are getting a straight line, right? So in the paper you have to write down for straight line, if it is tilted, you will say that velocity is increasing uniformly and acceleration is constant over here. If I will draw another line, which is a green line, you know that it is also a straight line as well. What do you think? If this acceleration is a1 and this acceleration is a2, what do you think? Which acceleration is bigger, the a1 or a2?
Sir, A2.
Yeah, exactly. So we'd say that a2 is greater than a1 because its acceleration is although uniform, but its speed is increasing very swiftly.
Yes, sir.
And then we will be drawing another graph over here. Let's say we have velocity in meters per second and time is in seconds only. Okay, into this graph, I will not make straight lines. Instead, I will make some curves. For example, like this one. So, although it is a downward curve, do you think that velocity is increasing or decreasing?
Sir, it's increasing at the beginning, but
It is increasing. Yeah, exactly. How will we say? How will we write down? We'll say that velocity. We'll say that velocity increases at
beginning.
uniform, or we can say that non-uniformly, and acceleration is A is for acceleration. We say acceleration is positive, but it is decreasing. It is what? It is
Decreasing.
decreasing. Yeah, exactly. That's, because it is a downward curve, so we say that it is decreasing. How do you know that it is decreasing? For example, you know that in, let's say this is first second. In the first second, it has covered this much, uh, this much part of the curve, and time, in the similar time, you can see that it will just cover this much part of the graph. First, it has covered this much. So we say that velocity is decreasing, velocity increases non-uniformly, but A is positive and it is decreasing as well. So when you will see that your graph will become a horizontal line like this, when you see let's say something like this, let's say this is point X, okay? So we say that at point X, V is constant, no, not at point, at after point X, I will say that after point x, v is constant, and acceleration is 0. You understand that? Hello? Hello? Ryan,
You hear me?
can you hear me?
Yes, sir.
Okay, so we will say that at point x, after point x, velocity becomes constant and acceleration becomes 0, right?
Yes, sir.
And then we have this graph. Over here, we can write down that we can say that velocity increases non-uniformly and acceleration is positive and it is increasing. You understand that? Because
Yes.
this is an upward curve, it shows that velocity is increasing, um, but it is non-uniform increase. So there is an acceleration. So acceleration is also not constant. Because acceleration is not constant, so it is also increasing, but this increase is positive increase, right? Can you hear me? Hello?
Yes, sir. I can hear you.
Okay. So there are other things to discuss over here as well, and it is that what are the characteristics of velocity time graph or speed time graph? There are two characteristics that are important. Number one, it is the gradient. We say that the gradient of velocity time graph is equal to the acceleration. Okay. Number two, which is more interesting, and we say that this is the area under the graph, which is equal to area under the graph of velocity time graph tells us the distance traveled by the object. It is equal to distance traveled by the object. You understand that?
Yes, sir.
You know that in when we studied characteristics of distance time graph, then we studied that it has only one characteristic, and it is that gradient of distance time graph give us velocity or speed. But velocity time graph characteristic is that its gradient gives us acceleration, and area under the graph gives us the distance traveled by the object. And how to calculate that distance? It is quite easier. For example, uh, examiner can ask you that what is the distance that object has covered from x to y in this graph. Let's say this is the value which is 20, and here the time was, let's say, 20, and here the time is you can say 25, something like that. So you see that we will label this graph and we will shade it. Okay, area under the graph which is being shaded. You know that this is a rectangle. So we say this area is equal to length which is 20 into width which is 5. You know that from here till here it is 5. So we said it is 100. So distance between x and y is 100 centimeters. Sorry, 100 meters, because we are using meter per second. Are you getting it or not?
Yes, sir.
Similarly, there, for different types of graphs, there can be different shapes as well. For example, I'm going to have another graph over here. We can say that graph is like this one. And then it comes like this. So you know that if there can be so many moments. For example, let's say this is a, or let me take some values. For example, if this is 10 and if this is 20, and if this is 5, this is, let's say, 15, this is 20, this is 22, this is 27, you can say. So from here you can see that um, if examiner will say that what is the distance in first 5 seconds, distance in time from 1 to 5 seconds. Okay, so you see that this is a triangle. So here we will apply the formula for triangle, area of the triangle, which is 1 over 2 times base, which is 5, and height is 10. And if examiner would say that find out area of the triangle between 5 and 15 seconds, again distance between 5 and 15. So we will say, because it is a rectangle, so from here till here the distance is 10. 15 minus 5, it is the length, and the width is from here till here, which is 10. You understand that? Hello? Hello? Ryan, are you getting it or not?
Yes, sir.
I think we are not active. Is it true?
No, sir.
Okay. Okay, then you see that if examiner would say us to find out area of between of distance between t, which is 15 till 20, how will we do it? It is quite simple. Again, this is 20 length from here till here. This length is 20. So we will apply the formula of a trapezium, 1 over 2 into sum of two parallel sides, for example 10 plus 20, into height, which is 5. Similarly, examiner can ask to find out the distance in the last 7 seconds from t. You know that from t till 27 seconds. You can do it like this one: 1 over 2 into. In this case, now this is a parallel line. This is a parallel. Both of these are parallel lines. So from here till here, this is 2, this is 2, and from here until here, this is 7. So we'll do it like this one: 2 plus 7 into height is 20. And if you would say that what is the total distance traveled by the object, we will sum all of these distances.
Yes, sir.
Is it understood or not?
Yes, sir.
Okay, we will continue doing this. Obviously, the idea will get more clear when we will do some past papers or
Yes, sir.
two questions like that of past paper. So we will finish our class over here. We'll see you tomorrow to solve.
Okay, sir. Allah Hafiz.
Yeah, love.